So let's go through the question and we'll label the parts and we'll just systematically kind of figure it out, okay? The first part says we have 27 items. Now, what do I do with that 27? It says that this is randomly selected. So this is our sample, okay? In other words, little n. And we've selected that from a larger population, larger, therefore capital N, okay, of 275 items. Now, the sample mean, and I can't do the X bar, so please forgive me. I'm just going to type it like that. So X bar, the sample mean, is 39. And it says the sample standard deviation. Now, luckily, I don't even have to worry about trying to type a sigma because sample standard deviation is little letter s equals 6. Now, I don't see that they've given us the population standard deviation, and so that is unknown. In fact, so much so that I'm going to write sigma is unknown. Now, what's the significance of this? The significance of not knowing sigma, which is the population standard deviation, is that what are we going to use? We're going to use the Z or the T table. We are going to use the T table, which actually most students prefer. It's maybe a little bit easier. Now, they want us to develop a 95% confidence level, or I'm just going to say a 0.95 confidence interval for the population mean. Now, you've included the answer here from the system, and you're saying, I don't even understand how to get started. Well, now that we have some labels, let's just kind of look down through here and see which pieces and parts we know. Well, 39. We know what 39 is. 39 is X bar. So we know where that piece comes from because the confidence interval is about the mean, and this is the mean, so we're going to go to the right and the left of the mean. Okay? Now, plus or minus, so we're going to go forward and backwards, right? Now, I'm going to start with these last pieces here. You've probably gotten familiar with the fact that you have your equation and you have to test to make sure that the sample is a certain percentage of your population. And so you're using your correction factor here, right? You know that you're calculating your adjusted sigma here, and I suspect that you're comfortable with that. Here's the 6 divided by the square root of 27, so you know where those parts came from. What you're missing is the 2.056, and probably you took half of that, went to the table that comes with our book, and you looked up 0.475, and you found, let's see if I can find it here, and you said that is nowhere close to the 2.05 number that was shown in the equation. That's because this is a case where sigma is unknown, so we need to use the T table. And in the T table, like I said, it's actually a little bit easier. This is again from your book. You look for our problem said, I'm sorry, our problem said a 95% confidence level, so I'm going to find, see, here's our confidence intervals, 95%, and I'm going to look down through here. Now, notice that this column is not n, it's degrees of freedom, and degrees of freedom is n minus 1. So, if our little n was 27, we're going to look for 26. We're going to go across here to where we're under the 95% confidence level, and that's where the 2.056 comes from. So that gives us all the pieces of the puzzle, and hopefully that clarifies and answers your question, and now you can solve that problem. I'm going to send you a link to this video, obviously, and also to another video where some students from a previous semester worked it's not this exact problem, it's a similar one, and hopefully between that it'll help your overall understanding. Thanks.